Hi, and welcome to this video in which I explore the use of a virtual keyboard produced on TouchOSC running on an iPad, or it could be on an iPhone, connected to SonicPi running version 2.12.0 MIDI Alpha 5. This is in fact the latest cutting-edge development version from GitHub, but some of you, if you support Sam Aaron on Patreon, giving him financial support to help develop SonicPi, will have access to version MIDI Alpha 4, and with a couple of lines changed, which I'll show you later, this will work on that. And I'd certainly strongly recommend purchasing TouchOSC, which is not that expensive and gives you a lot of flexibility and use with SonicPi in particular, and with other MIDI devices that you may have running on a Mac. So what have we got here? Well, let's start off by looking at the TouchOSC side, and perhaps the easiest way to do that is to switch to the TouchOSC editor, which I have running here, and you can see that this is set up for an iPhone or iPod Touch size screen, and the one that's running on my iPad is actually the same thing scaled up, which happens automatically and lets you use it with the keys slightly more widely spaced so that it's possible to play chords on the iPad, whereas it's quite difficult to do that if you're running this on an iPhone, but it's certainly very acceptable for playing a single note at a time on an iPhone. So how does TouchOSC work? Well, basically when you start with a template, you get a black screen, which is here. The strip across the top here just enables you to put more than one screen on the same application, and you can switch between them. But in this simple case, we only need one. And in this black area, you insert icons like this one, which is a multiple toggle switch running in exclusive mode here, so that only one of the four switches can be selected at a time. There's two of these, one which I've called octave switcher, is labeled by this simple label above it, and the other one which is called synth selector, which is labeled by this label above that. There are two other very similar icons here which are sliders, and this one I've named volume and given a label vol in the same color so that you know which one it is, and this one is labeled rel, which is short for release, and will adjust the release setting of the note which is going to be played. Down the bottom we've got a 2-octave keyboard, which is done with a series of individual discrete switches done in different colors. The white notes are actually here green, and the black notes are up here. But they are essentially the same thing, just different sizes and placed overlapping with the black notes on top, so it's possible to click a black note without clicking the green one underneath it. And you'll notice that if we click on one of these, that we've got various settings for what are associated with this particular key, and we're interested in the MIDI setting here, and it's going to have a value which is of type note, so it's a MIDI note. It's going to be produced on MIDI channel 1, and it is the note corresponding to C octave -2, which is in fact a MIDI number of 0. The next note up, which is this one here, is going to have a MIDI note value of 1, that's corresponding to C sharp in that -2 octave, and so on all the way up. You can see the MIDI number is increasing to the top note there, which has a MIDI number of 24, corresponding to the C in octave 0. If you were programming that in SonicPi, it will be :C0 for the note name. You'll notice also that there are two things associated with this switch. It produces a velocity setting, which is the velocity with which you're tapping a note, if you like, on a standard keyboard, of 0 if you're not touching it at all, up to 127 if you're really thumping it. Now in this case we haven't got touch sensitive keys, and therefore we have got just a 0 when it isn't pressed and 127 when it is. If we come back to the octave switcher again, this is part of what's called a multiple toggle switch, and if I try, and it's quite difficult to get this to work, there's so many program's running. There we go. Oh, no. Yes. If we try and get down to here, we can bring up another multiple toggle as if we were going to put that onto the screen. We don't actually want this. This is just to illustrate it. And you can see that actually they're two-dimensional structures. This one has got 5 rows and 5 columns, whereas the one that we've got here, the two we've got here, have just got 1 row and 4 columns. Now when you address these, you address them first of all by the row and then by the column. So in this case, we would have up from 1, 1 in the bottom left-hand corner up to 5, 5, I think top right. But in this case, we've got 1, 1 to address that switch and 1, 4 to address that one. Now we do that when we want to send information back to the switch, because they will also respond to receiving OSC messages sent into TouchOSC. And there's a mechanism whereby we can send an OSC command from SonicPi to the TouchOSC, and when it gets there, it needs to know where it's to be sent. Well, this depends upon what it is you're looking at. The black page there, I've given a name and called it KBD, short for keyboard, since that's what this is all to do with. And then on that, next level down, on top of that, we've got a switch which I've called octave up here. So /KBD/octave is the address of that switch. And within it, we do /1 to address this row, followed by /1 for that, /2 for that, /3 for that, /4 for that. We then supply it with one bit of data, either a 0 if it's going to be off, or a 1 if it's going to be on. In the case of the slider, we have a slightly simpler name for it. I've called the slider volume, and so /KBD/volume is the name of that slider, and /KBD/release is the name of that one. Again, the values go from 0 to 1, but they are continuous, so we can have anywhere between 0 and 1, say 0.5 for halfway, 0.8 for 80% of the way, and so on. And so that, I think, describes what we need to see about this. We can get rid of the editor now, and down here I've got the screen in a window which is essentially QuickTime trying to record something. It's actually just sitting there waiting to start the recording, which I'm not going to do. It's simply a convenient way to get a picture of the iPad on this screen, which is being recorded and appearing in the video, without having multiple cameras and other difficulties to set it up. So having looked at that side, let's now move over to the left-hand side to SonicPi. And the program is not that expansive to do this. It fits all on the screen here. There's perhaps a couple of words off the edge in the comment section, but I think you can see everything that's necessary here. And at the moment, as I say, I've got a version for MIDI Alpha 5 here, and we'll talk about the 2 lines that need to change for MIDI Alpha 4 in a minute. Now, the other thing which is most striking, if you've not seen any of the development versions for MIDI in SonicPi yet, is that we have an extra screen section which can be switched on in the logging section, and this gives us the ability to see all of the cues, external cues and internal ones, which are coming into SonicPi. And the cues in this case are of the form /OSC/MIDI /TouchOSC_bridge /2/1/control change if we are doing something to any of the switches or sliders along the top. And it is the same thing with /note on or note off if we are pressing any of the keys down at the bottom here, the note keys. And having done that and ascertained which it is that we are looking for, we can set up SonicPi to look for this particular string and to be triggered by it, and then to supply us the data which is in the square brackets here. And we've got 2 numbers supplied for a control change. The first one is the control that we are actually altering. And you remember that we numbered these from 1 to 4 for this one, 6 to 9 for that one, 5 for the volume slider, and 10 for the release one. The reason the release one is so high is that I added it after I'd had the other three operating as an extra feature. So that's why it's out of step with the others. And the second digit is the data which is being provided. In the case of a switch, it will be 0 if it's off, and it'll be 127 if it's pressed. In the case of the slider, it will be a number between 0 and 127, depending upon the state of the slider. And in the case of the note, in this case where we haven't got a touch-sensitive keyboard, it'll be 0 if the key isn't pressed and 127 if it is. And instead of the control change number, we will get the MIDI note number here, which you see I've set up from 0 up to 24 for these keys, and which we can modify by adding an offset so that we can get the note in a sounding range. Rather than MIDI notes 0 to 24, we might start at 48 and go up from there, or indeed from 36 or from 60, depending upon where we want to go from. Right, let's look further at the program. First of all, the difference that we get between the MIDI Alpha 5 version and the MIDI Alpha 4 version occurs in these two sync lines. That's lines 22 there and 43 down here. The difference is that in version 4, Sam hadn't differentiated on the source of cues, and therefore it started off with /MIDI/TouchOSC bridge. There was no /OSC on the beginning, which you'll notice is there. If I load in a minute the version 4 program, you see it's exactly the same, except we haven't got /OSC in the beginning of that line. Secondly, where it says TouchOSC bridge, you'll notice that that's all in lowercase here, whereas actually, normally TouchOSC bridge, the program is running up here, has got a capital T, capital OSC, and a capital B for bridge. This, by the way, is a little utility provided with TouchOSC, which runs on the host Mac that you're using, and it enables the signals either sent in via USB or via internet to be picked up from the iPad and converted so that they appear to be coming from a MIDI device on your Mac called TouchOSC bridge. And the difference is that because it's difficult to know when you've got capitals and not, or in the case of these strings, all of them will be forced into lowercase. So even though externally it's called TouchOSC bridge, as far as trying to get the cue triggering is concerned, you put it in all in lowercase. So at that stage, let's just have a brief look at the other version of the program for Alpha 4 keyboard. And here you can see, as I was saying, we start off with the sync starting /MIDI, and we've got TouchOSC bridge with the capitals in the appropriate places. And the same with the line down the bottom here. Otherwise, the programs are identical for the two versions, though who knows, there may be slight changes in syntax still to come. As Sam is always at pains to point out, if you use an alpha version like this, you have to be prepared for changes to take place, and then work out what they are and amend your program to suit. Right, let's now just have a little bit more of a look at the program before we actually run it. Now, once we've started running the program and we position sliders and the octave switches, then SonicPi will know where they are because it would have received signals from them. But when we first start running the program, we've got to set up some sensible default values to start off with, and so we're going to use OSC commands to send the initial values from SonicPi back to those switches and sliders so that it can adjust them to be in keeping with what's actually happening in the program. And perhaps one further thing just before I say that, the second line of the program there says MIDI port 2, and if we look at one of the sync cues here, you can see it goes OSC MIDI TouchOSC bridge, then /2/1. The 1 is MIDI channel 1, and you notice, you remember when I was describing the editor in TouchOSC, I'd set all of the command switches to operate on channel 1. The 2 is the device number that this Mac sees TouchOSC bridge at. Now that depends upon whether you've got any other MIDI devices set up and running on your machine. And so in my case it's 2 here, but I have had it with perhaps another keyboard running as well as 3 or even 4 if I've had further MIDI devices connected. So you have to be prepared to see what's coming up here and make sure that MIDI port 2 is set to 2 there. It's just by setting it once there, you don't have to scrabble into the middle of this line and set it there and down here. This line actually gives exactly the same as the ones over here, except that you've got the MIDI port 2 explicitly supplied in that case. So we're going to send an OSC message to TouchOSC, and this is set up by saying use OSC 192.168.150 is the IP address of my iPad, 9000 is the port that TouchOSC wants to use, and if I temporarily come out of that, you can see that here. If I go to OSC there, it says that it's sending OSC down here. It's a bit small to see. It's sending OSC to my host 192.168.115, which is my MacBook here, and its outgoing port is 8000, the incoming port is 9000. So we'll just put that back again, go back to the screen here. And so that sets up the route that they're going to go. And here are the messages we're going to send. For the keyboard octave switch, remember its address was /kbd/octave /1 for the first row, and then number 2 means the second switch position across, and therefore that is going to turn on when we run the program this switch position and turn off that one. And that corresponds to an octave offset of 48. Now we can see that down here in the program where that is actually done, which is in this section of the program down here. If we get a sync pulse, which is for a control change, and the B0 value, that's the first number down here, is in the range less than 5, in other words, it's not 1, 2, 3, 4, we're not using 0, so it's 1, 2, 3, 4 as far as we're concerned, and B1 is 127, that means that we've actually got something pressed. Then it's going to set the octave offset to 24 plus B0 times 12. Now if we've got the second switch pressed, B0 is going to be 2, 2 times 12 is 24, 24 plus 24 is 48, and that's what the octave is set to. And so by setting that switch, we're agreeing with the first value that we've got here, which is 48. Because we've set it externally, it's not actually been pressed, it's just been turned on the screen. It won't actually send a MIDI signal back again, so that's why we set up oct offset directly in the program here for the first time. Similarly, the amplitude setting, which will be the volume we're going to use, is 0.5, and that is set here by sending an OSC command to KBD volume, that's the volume slider, and setting its slider position to 0.5, which is halfway up. Incidentally, just before that I've got sleep 0.1, as I've found by trial and error that if you send a lot of OSC messages in quick succession from SonicPi to TouchOSC on an iPad, that occasionally it can miss some, so it's just to give it a slight chance to finish processing the first one before the second one arrives. I don't think it's a problem with SonicPi. I think it's rather a problem with the iPad and with its processing the input information there. So another 0.1 sleep there, and then we set the synth switch to position 3, which you can see there, and that corresponds to the third synth, which is SAW, and that is set normally by MIDI signals coming back from the control when we select the switch on the iPad in this section of the program down here. And you can see that if the B value which is being received when the control change is bigger than 5 and less than 10, in other words it's 6, 7, 8 or 9, and there is a button pressed, we've got a 127 signal coming for the second number, then we're going to choose the synth that we're going to play from a list, piano TB303, SAW or FM, And B0, if the third position is selected, is going to be, that's control number 6, 7, 8. 8 minus 6 is 2. An offset, remember we're starting from 0 when we're looking through a string like this. 0, 1, 2 would select the SAW synth, which is the one that we've specified for the initial value here. And finally, for the release setting, we are setting that to 0.167 or 16.7% of the way up from the bottom. Why that strange number? Well, if you look down to where this is worked out in the last part of this live loop here, if B0 is equal to 10, that means that the release slider has been moved. Then we're going to set the value of rel to B1, change to a floating point number so that we can get a fraction where we divide it by 127. And that's going to be a number between 0 and 1, multiplied by 0.9, which gives us a number between 0 and 0.9, plus 0.1, which gives us a number between 0.1 and 1.0. That's just so that we can't make the release too low, because if it's set down to 0, you won't hear anything. I know I let the volume go right down to 0, but I thought it was a bit confusing. Maybe you're not sure what was going wrong if you weren't hear anything. So I've limited the release minimum value to 0.1. And if you put the numbers in for 0.167, 0.167 times 0.9 plus 0.1 should work out at 0.25, the initial value we've set. So that is dealing with the live loop control, which is going to be triggered by any control signal being received on the relevant MIDI port and channel. And the live loop mPlay is the one which is going to play a note, and that is triggered when it receives a note on value on channel 1 and on our MIDI port from the TouchOSC bridge. And we get the value of the note, MIDI note in B0, but remember it's in the range 0 to 24. So in the bottom line here, we add the octave offset to it. And I've set a small attack of 0.05 there, because otherwise it sounds a bit clicky, and so it just smooths things out slightly. I don't want to make it too big, because otherwise percussive things like a piano wouldn't sound too great. You could play around with that maybe a little. And then we get the amplitude that we're using, and that is set by the amp value, which initially is 0.5, times the value in B1, changed to a floating point divided by 127. This is actually a bit of overkill here. We could almost miss this out in this case, because B1 is either going to be 0 or 127. We haven't got touch sensitive keyboard. And then we've got a release. So if it's 127, then of course that's just the amp setting is equal to amp there. And then finally the release is given by the rel value. If B1 is not equal to 0 bit, I put in, because note off values, I'm not sure whether Sam's done this. I know he gives separate cues for note on and note off, but often in MIDI, note off signal is actually supplied as a note on with a velocity of 0. And so you have to distinguish between those, otherwise you can get a double triggering when the note is released, which you don't really want. But the fact that we've got the amplitude setting in there, that's possibly a bit of overkill, having that if B1 is not equal to 0 at the end. So I've been exhaustively through the program. You've all gone to sleep, so let's just wake you up by playing something. I want you to look at the image down here of the iPad as I run the program, and you'll notice the switches being set up to the values that we've specified when we run it. 3, 2, 1 now. And you can see that the octave switch select has gone to the second position down here. The volume setting has gone halfway up. The release has gone to 16.7%, and synth's gone to the third setting. And you'll see the in the log here, we've got the OSC messages being recorded there, which set those 4 values. You'll see also that we've got 2 control changes coming back from control number 1. That's that one, which was initially on. It's now telling us that it's off, because it's sent back a signal that I've been turned to 0, and Control 9, that one was originally on, it's now off because that one's gone off and that's gone back to 0. But because we didn't actually tap these to do them, we just sent it by an OSC signal, backdoor, it doesn't actually send back a MIDI signal to the to a SonicPi, but it will do if we were to change it subsequently. Let's just play a note or two. That rather quiet, so let's put the volume up and maybe put the release time up. See, it's quite playable as a keyboard, as long as you're reasonably nifty with your finger work. And we can now look at the entire range that we can get on this. Let's start at the bottom. Up an octave. Up an octave. Notice the changes on the top part of the keyboard, which is also, I put print statements, put statements in to show what's happening, and then the final octave. You can see we've now got an offset of 72. They go back there, the offset's down to 36, so we drop down and then drop down to the bottom again. And you can also, let's just change to a different synth. Okay, chords as well. So quite a nice little system, as you can see. The one thing you can't do is to do glissando, because if you slide your finger along, it only the first note stays on until you take your finger off the screen. These will actually move when you do it the multi-toggle switches, because only one can be on at a time. And you could, I suppose, do that with a keyboard, but you'd have to have the black notes, the entire length of the light green coloured notes, and it wouldn't look like a conventional keyboard. So if you're at all musical and you're used to hopping around a keyboard, it would be quite hard to work out where to go. So I think it's worth doing the fact you've actually got to lift your finger off the keyboard between tapping one finger and the next one. But it gives quite a nice little instrument, which is a lot of fun with SonicPi, and you can even play well-known songs which usually feature in quite a lot of my SonicPi programs, but it's an easy one to do, which is this one. With the odd mistake. Well, it's a long way since the first time I played Frere Jacques on version 1 of SonicPi. It's slightly different. Things have moved on a huge amount. I will make the code for this available with links below this video, and also supply a copy of the TouchOSC template for this. TouchOSC files are essentially XML files which are zipped, and it's fairly easy therefore to distribute them as text files, and I will introduce some notes as well which will tell you how to put it on TouchOSC if you've got that. If you haven't and you've got a Mac and you're into MIDI, I would thoroughly recommend it as a very nice little program, not at all expensive, and gives a lot of fun using this, and very useful for helping to understand how OSC in particular works. So thank you for watching, and hope you've enjoyed the video.